This lesson will take you through sections 5.1 and 5.2 in your textbook. First, please pause this presentation while you do this warm-up question. Please write an equation in slope-intercept form of the line that passes through these 2 points, 10, 4 and 0, 1. Once you've written the equation of a line that goes through those points, identify the slope of the line and one point on the line just by looking at the equation, not at a graph of the line, but at the actual equation itself. When you finish doing this, you can resume this presentation to see how you did. Alright, so let's check and see your work. The solution to this problem involves finding out what m and b have to be for a y equals mx plus b, or slope-intercept form of a line that passes through 2 points. The 2 points we're interested in are 10, 4 and 0, -1. So the question is, what are m and b for a line that passes through these 2 points? Let's work on finding the slope first. Remember, the slope is the rise over the run of the line. To find the rise of the line, we see how much y changes as we go from one point to the next. When we go from 4 down to -1, we're going down by 5, so our rise is -5. The run is what we get when we go from 10 down to 0. In this case, we're going down by 10. So the rise over the run is -5 over -10. When we simplify this fraction, a negative over a negative gives us a positive, and 5 over 10 simplifies to 1 over 2. So the slope of our line is 1 over 2, or 1/2. We can plug that into our y equals mx plus b equation. Now we just need to find b, the y-intercept for this equation. This is particularly easy in this problem because the y-intercept is one of the points that we were given originally. Remember, the y-intercept is where the line crosses the y-axis, and at that point, the x-coordinate is 0. So we can tell just by looking at our table that the y-intercept here is -1, and we can complete our y equals mx plus b equation by plugging -1 in for the y-intercept, or b. The second part of the problem said, tell just by looking at the equation what the slope and one point on the line are. So you can tell by looking at the equation that the slope is 1/2, and that one point on the line is the y-intercept, 0, -1. If you're given the equation of a line in slope-intercept form, and you're asked to find either the slope or one point on the line, you don't have to do any computation or calculation at all. You can simply look at the equation of the line and spot the slope and the y-intercept. As a reminder, slope-intercept form looks like this: y equals mx plus b. M is the coefficient, or the number in front of the x. B is the constant term. It's the number that's all by itself. Remember that because addition follows the commutative property, it doesn't matter whether I write y equals mx plus b or y equals b plus mx. The slope is always the coefficient on the x, and the y-intercept is always the constant term. So when is it useful to describe a line using slope-intercept form? Well, if you already know or can easily find the slope, and you know where the line crosses the y-axis, that is the y-intercept, you can very quickly write the equation of the line in slope-intercept form. Sometimes the equation of the points in the line will be given to you in function form, not in y and x form. But don't let this confuse you, because the basic process of finding the slope and the y-intercept are the same. Suppose the problem said, write an equation for the linear function f with values f of 0 equals 5 and f of 4 equals 17. It'll be helpful to remember that f of x equals y. F of x is another way of writing y. And so x is the stuff inside the parentheses in f of x. It's the input to our function. And y is the output. It's what we get when we drop x into our function. If we remember this, we can translate the function form values we were given into things that look more like coordinate points. So f of x equals y. That means that when f of 0 equals 5, that's another way of writing the point 0, 5. And f of 4 equals 17, that's another way of writing the point 4, 17. Now we have 2 points, and we're asked to find an equation of a line that goes through those 2 points. This is just like your warm-up then. We can place those 2 points in a table. Instead of having an x and y table, now we have an x and f of x table. And we can find the slope of the line by comparing the rise and the run and spotting the y-intercept in the table. And when we do that, we get that the function is 3x plus 5. So this is a function that meets the criteria in the original problem. F of 0, that is when we drop in a 0 to this function, what it spits out, the output, is a 5. F of 4, when we drop a 4 into this function, what it spits out is a 17. But what happens if we're not given the y-intercept? For example, suppose a problem says, write an equation of the line that has a slope of -4 and passes through the point -1, 3. What do we do in this case? Well, we know that the slope is -4. That was given in the problem. And we know that when x equals -1, y equals 3. So what we can do is we can find the one thing we're missing, the y-intercept, by plugging what we do know into the equation of the line in slope-intercept form and solving for what we don't know. So we're going to plug what we do know into y equals mx plus b. We know that the slope is -4, so we plug that in for m. And we know that when x is -1, y is 3, so we plug those two values in for x and y at the same time. And we still don't know what b is, so we leave that as a variable. When we simplify this equation, we see that we have an equation with a single variable, b, and we can solve for b. When we do that, we find that b has to be -1. Now we can write the equation of the line that passes through the point -1, 3 and has a slope of -4 because we know both m, the slope, and b, the y-intercept. And the equation would be y equals -4x minus 1. I'd like you to pause this presentation and work through this practice problem. Write the equation of the line that passes through -2, 5 and 2, -3. Remember, step 1 is to find the slope. Step 2 is to use the slope in either point to find the y-intercept. And step 3 then is to plug the slope and the y-intercept in for m and b in the y equals mx plus b equation. When you think you've got it, please resume this presentation. What you should have gotten is y equals -2x plus 1. If this isn't what you got, please go back and check your work again. If you're still feeling stumped, bring your work into class and we'll go over it together. So what's a real-world situation that we would use slope-intercept form to model? Well, cell phone plans typically follow a linear equation model. Typically, you pay a fixed monthly fee plus a number of cents per minute for each minute that you talk. So your total monthly cost is the cost per minute times the number of minutes plus that monthly fee. The cost per minute is like the slope. It's the rate that your total cost goes up for each minute that you talk. And the monthly fee, that's the b, that's the y-intercept. That's how much you pay whether you talk at all or not. You can see below, I've graphed a simple equation. In this case, the monthly fee is $10 and the cost per minute is 5 cents per minute. The red line represents the cost varying with the number of minutes that you talked. So you could tell from this graph what your cost would be if you talked for 200 minutes or 400 minutes, etc. This is the end of this presentation. Please feel free to go back and fill in any blanks that you're missing in your notes, and I'll see you in class tomorrow.